Let's talk now about a very common research design in political science and three things that can happen when you control for a potential rival cause of a dependent variable. We're going to look at spurious relationships, additive relationships, and we're going to look at interaction relationships. These are the three possibilities of relationships that can happen when you control for a rival explanation. Now here's the key question. This is a rhetorical, a heuristic. Control comparisons require that we always ask the how else question. When we look at the relationship between an independent variable and a dependent variable, and we see a relationship, we must ask this: how else, other than the independent variable, are the groups I'm comparing not the same? A controlled comparison is accomplished by examining the relationship between independent variable and dependent variable while holding constant other variables suggested by rival explanations and hypotheses. So if you hold a rival constant, as you vary the independent variable from one value to another, but if the rival variable is held constant, then any differences in the dependent cannot be attributed to that rival cause. There may be other rival causes, but you've held that particular cause constant. Let's return to the recurring example in the textbook, which is the relationship between partisanship and gun control opinions. Here's the hypothesis. In a comparison of individuals, Democrats are more likely to favor gun control than are Republicans. And sure enough, if we did this simple comparison, we'd find this: 64% of Democrats favor gun control compared with only 25% of Republicans. So we are tempted to draw the conclusion that our theory, our explanation about the linkage between partisanship and gun control opinions has causation in it, that somehow partisanship is causing this difference in the dependent variable. But now we must ask, how else besides partisanship are Democrats and Republicans not the same? The answers to how else questions are always compositional differences across values of the independent variable. Let's have a look at this. A compositional difference is any characteristic that varies across categories of an independent variable. But besides the independent variable, there are other things that are going along for the ride and also varying. We can think of lots of differences between Democrats and Republicans besides their partisanship. They may differ in income. Democrats may on average have lower incomes than Republicans, for example. We know that the racial composition of partisans is quite different across values of partisanship, race, gender. The example in the book is using gender as a compositional difference to examine the relationship between partisanship and gun control opinions. In fact, Democrats and Republicans may have compositional differences in many other ways that we have not thought of. And since we don't have random assignment as a tool in our methodological toolbox, we now have to worry about these rival explanations as confounding our favorite hypothesis about partisanship and gun control. Now here's a key point. If a compositional difference is a cause of the dependent variable, then changes in the dependent variable may be plausibly attributed to the compositional difference, not the independent variable. I mean, there's a couple of ideas going on here. If you find a compositional difference across the independent variable, and let's use gender for example, but that compositional difference is not also related to the dependent variable, then you don't have to worry about anything because there's no causal linkage between the compositional difference and the dependent variable. But if the compositional difference is also a cause of the dependent variable, then we have to control for its effects because we may be confusing the effect of the independent variable with the compositional difference. And here's some standard notational nomenclature when we start talking about variables x and y and z. They have certain representations here. Let's introduce them. The independent variable is represented by x. This is just by convention. The dependent variable by y. A rival cause is represented by the variable z. In the partisanship explanation, party identification is x because that's featured in our favorite hypothesis. about party ID, and gun control opinion is what we think is being caused by X, and gender represents a potential rival, a rival causal variable Z. Now here's the logic of controlling for Z. Imagine that individuals have different values on X. So this group of individuals are Democrats and this group are Republicans, but they share the same value on Z. So all of those who are Democrats we're comparing are women, and all the Republicans are women that we're comparing, and same token, male Democrats and male Republicans. Then changes in Y across values of X cannot be caused by Z because Z is being held constant. We're not permitting it to vary. We're holding it constant as we make this comparison across values of X. That is, compare female Democrats, for example, with female Republicans, and compare male Democrats with male Republicans. That's the logic of control comparison. We neutralize the effect of a rival cause by holding it constant, by not permitting it to operate. Now, I should emphasize that if we were to find a partisan difference among females and a partisan difference among men, that doesn't mean that it's only partisanship that's causing the differences on Y, but we have ruled out gender as a potential rival. We've held it constant, not permitting it to operate. All right, that said, let's introduce each of the three scenarios of what can happen to an XY relationship when Z is controlled. The first possibility is spuriousness. That is, the relationship between X and Y turns out to be coincidental, not causal at all. In a spurious relationship, the control variable Z, and this is important, defines a large compositional difference across values of the independent variable X. So we know that link between X and Z, between Z and X, is going on. You know, as you change values of X, you're changing values of Z. Further, and this is where the mischief comes in, this compositional difference is a cause of the dependent variable Y. So I often think of spurious relationships as sort of like Z is like a puppet master, causing or having a relationship with X, making X move, if you will, and then also making Y move. And since X and Y are moving together because of Z, the XY relationship you think is real, but it's really an artifact. It's artificially created by the activity of Z. So what happens then is, after holding Z constant, the empirical association between X and Y turns out to be completely coincidental. It's not causal at all. It was created again by Z varying out there, and we weren't controlling for Z. When we did, XY became 0. Now here's a happier scenario. In an additive relationship, and here again is the key. In an additive relationship, the control variable is a cause of the dependent variable. Okay, that's good. But I should say, and also it defines a small compositional difference across values of the independent variable. So the linkage between Z and X is weak or non-existent. Z is kind of a free agent affecting Y, and X, unaffected by Z, is also a cause of Y. And so both variables are contributing to variation in Y. They add to each other. They support each other. Because the relationship between X and Z is weak, that's the key linkage here, X retains a causal relationship with Y after controlling for Z. In an additive scenario, the control variable Z also helps to explain the dependent variable. So you're getting a better, more fully specified explanation of Y by adding Z, and you're not detracting from the effect of X on Y. This is the most complex scenario, and it's rather common in political research. So let's have an introductory look at it here. In an interaction relationship, the relationship between the independent variable and the dependent variable depends on the value of Z, depends on the value of the control variable. So for example, just a generic example, description. For example, let's say for one value of Z, the XY relationship might be stronger than for another value of Z. So just to jump ahead a little bit, let's say when we look at males, let's say the effect of partisanship on gun control opinions for males is very strong, in that the percentage of Democrats favoring control is much higher than the percentage of male Republicans favoring control. But when you look at women, perhaps the relationship is there, that the Democratic women are more likely to favor control than the Republican women, but the relationship might be much weaker. This is one form of interaction. The confusing thing about interaction is it can assume several different forms. All right, now let's use some stylized examples to get at the problem here. Let's say we haven't controlled for anything. We have 12 Democrats represented here on the left, this circle, and we have 12 Republicans represented here on the right in this circle. And of the 12 Democrats, 7 of the 12 favor gun control, and of the Republicans, 5 of 12 favor gun control. So we're looking at a percentage, I guess the percentage of Democrats here is about 58% favor control, and the percentage of Republicans is 42, 43%. So if we are doing this simple comparison, we would want to conclude, we'd say, well, the uncontrolled relationship shows that partisanship is having an effect. Now here's how spuriousness can make us think we're looking at a genuine relationship when in fact we are not. We're looking at something that's created by a large compositional difference. Here are the same 12 Democrats and the same 12 Republicans, but now we are representing their genders as well. And of course these are stylized examples, so I've made it very plain. Look at the Democrats. There are 12 Democrats, 8 of them are women. All right? Go over to the Republicans. There are 12 Republicans, only 4 of them are women. So from the beginning here, we are dealing with a very large compositional difference. We're comparing a group that is comprised of 2/3 are women, and over here we're looking at a group where only 1/3 are women. So that's the XZ relationship, the large compositional difference. Well, so what? The so what is the compositional difference also is very strongly related to the dependent variable gun control. Overall, if we add up all the women, we've got 6, 9 of the total 12 women are in favor of gun control. That's what's that. 75% of all the females represented in this graphic are pro-control, and you've got only 3 of the 12 males overall that are pro-control. So that's like 25%. So not only is there a large compositional difference, but there's a very strong relationship between Z, gender, and the dependent variable. Now let me say a few more things about the diagram, then a couple of follow-up slides will clarify. What percentage of female Democrats are in favor of control? Well, we've got 6 out of 8, which is 75% of female Democrats are in favor of control, and then you've got 3 out of 4 of the female Republicans, which is also 75%. So if you hold gender constant for females and you move across values of partisanship, there's no effect of partisanship. The same percentages of women in both parties favor control. Same for men. You got 25% of the male Democrats favor control. That's 1 out of 4, and 2 out of 8 for Republicans. That's also 25%. So what's the effect of partisanship on gun control opinions for women? Is 0. 75% versus 75%. What's the effect of partisanship on gun control opinions for men? 0. It's 25%, 25%. The whole relationship is being artificially produced by this huge compositional difference and this very strong relationship between gender and gun control opinions. All right, let's review that. Here's the dynamic behind spuriousness. In our example, gender, Z, defines a large compositional difference across the values of partisanship. 67% of Democrats are females, and about 33% of Republicans are females. So that's a big compositional difference. And gender, Z, is also strongly related to gun control opinions. Overall, 75% of women are pro-control, and overall, only 25% of males are pro-control. Finally, when we hold gender constant, that was the last observation that was made about the graphic. Of the Democrats, 75% of the female Democrats, 6 out of 8 are pro-control, compared to 75% of female Republicans, 3 out of 4. Now again, there are a lot more female Democrats than female Republicans in this representation, but when you control for that, you see that identical percentages are in favor of control. So for women, X has no effect on Y. Similarly, 25% of male Democrats, 1 of 4 are pro-control, compared with 25% of male Republicans, 2 of 8. Again, there are a lot more males in this representation among the Republicans than among the Democrats. But once you take that into account, you find that X has no effect on Y for males. Now let's give some graphic support to this. Let's graph the set of relationships. Here's what a multiple line chart looks like of the relationship that we just discussed. Here are the females. Every person along this line, or between these 2 points, Democrat and Republican, is a female. So we look at the percentage of female Democrats who support control, 75%. 75% of Republican females support control. You know, if I could have put like a bubble chart on this to show the numbers of females, the bubble over here would be very large and the bubble over here would be much smaller, but taking that into account, partisanship is just having no leverage. It's not having any effect as you move from Democrat to Republican among females. Same for males. Here's that 25% of Democrats who favor, 25% of Republican males who favor. And if I did the bubbles again, it'd be a small bubble over here representing fewer male Democrats and a larger bubble over here representing male Republicans. But taking that into account, there's no effect. All of the relationship, all of the graphic space here that is being explained, if you will, lies along the differences between the lines, or is represented by the differences between the lines, which is just a huge gender gap on this issue with no partisanship effect at all. All right, now let's take a look at something very different, an additive set of relationships. Here are the circles again. Without getting too far down in the weeds here, let's just let's just see if there's a compositional difference. As we move from Democrats to Republicans, that's the first thing to look for. How else do these two groups differ besides partisanship? Is gender an answer to that question? And it is not. I mean, over here we see that, let's see, 6 of the 12 Democrats are females, okay? And then 6 of the 12 Republicans are females. So right away, we don't have to worry as much now about spuriousness. We don't have to worry about spuriousness at all because we have no compositional difference across values of X. And that's a good thing. Now, what else is going on here? If we look at the females, look at female Democrats. What percentage are in favor of gun control? Well, it looks like 4 of 6, which is, what, 66, 67% are in favor of control. Now let's look at the females on the Republican side, 3 of 6. So 50% are in favor of control. So as we hold gender constant among females and we move from Democrat to Republican, we do see a partisan effect. That is, the female Democrats, percentage-wise, are about 17 percentage points more likely to favor control than the female Republicans. All right, let's see what happens with the men. Let's go over to males here. 2 of 6, which is about 33% of the male Democrats are in favor. And over here, support among the male Republicans is very low. It's 1 of 6, which would be about 16%, let's say. So we go from about a third, 33% to 16%. It's another 17-point effect for males on the basis of partisanship. Here's the dynamic, and let's just review what we were just looking at there in the diagram. Gender, and this of course is the linchpin point here, does not define a compositional difference across the values of partisanship. 50% of Democrats are females, 50% of the Republicans are females, so we have therefore a compositional difference that's not a difference. It's just a compositional parameter. The parties are equal in terms of their gender composition. And a point I did not emphasize, gender overall is related to gun control opinions. We could go back and review that, but if you look at all the females that were represented in that diagram and look at all the males that were represented, 58% of females are pro-control and 25% of males are pro-control. So just to review these two main bullets, gender is not related to partisanship in this representation. So if we had a relationship between Z and X and we're trying to represent it, we just wouldn't put we would say, well, they're just unrelated. There's no arrow or there's no line between them. And on the other hand, Z is a cause of Y. So it's acting independently to affect values of Y. That's the dynamic of additiveness. And again, to review, let's hold gender constant and see what happens. 67% of female Democrats are pro-control, compared with 50% of female Republicans. So if you subtract 50 from 67, this is a sort of a quick and dirty way to measure the strength of every relationship. For women, you would say that partisanship has a 17-point effect. All right, let's turn to males. 33% of male Democrats are pro-control, compared with about 16% of male Republicans. And that's also, if someone would ask you, what's the effect of partisanship among men, you'd say, oh, it's 17 points. In that Democratic males are 17 percentage points more likely to support control than are Republican males. You would say the same thing about females. The signature of additive relationships is that the effect of X on Y, in this case partisanship on gun control opinions, has the same strength and runs in the same direction for both values of the control. That is, it runs in the same direction because Democrats are more likely to favor control than Republicans, and it has the same strength because both effects are 17 points. There's a symmetry there to all additive relationships. Here's what the line chart looks like, and see how much more beautiful this looks than the spurious representation. Here again are the women, and this is the effect as you trace along the line's dropping for women. That means that partisanship is having an effect. It's producing a gradient for women. You know, would someone say, well, isn't gender causing this? No, it can't be, since everyone's a female. Then down here, we see the same strength of the effect, about a 17-point drop for males as you read along the line from Democrat to Republican. The distance between the lines is the effect of Z on Y. You can see this large gender gap for Democrats and an equally large gender gap for Republicans. All right, now let's look at something that's asymmetrical but very interesting. You know, we've just gotten sort of into the habit of looking at compositional differences and effects on Y. Let's just focus this discussion, focus on the effect of partisanship among women and the effect of partisanship among men. Let's see. Let's look at female Democrats. There are 7 female Democrats. 4 of the 7, which is about 57% of female Democrats, are in favor of control. 4 of the 7. Let's look at female Republicans. Well, 2 of the 4 female Republicans, which is 50%. So if you're just looking at women, you're trying to determine the effect of partisanship, you would say, well, it's going from 57% here to 50% here. Does partisanship have an effect for women? Yes. Subtract 50 from 57 and you get a 7-point effect. Now, let's switch to men. We've got 5 male Democrats. 3 of 5, which is 60% of the male Democrats, are in favor of control. 60%. We come over here, 3 of 8 male Republicans, which is about 38%. So for men, we're going from 60%, 3 of 5, all the way down to 38% in favor among Republicans. So what does this mean? Well, the effect for men, if you subtract those 2 percentages, you see a 22-point effect of partisanship for men. So the effect for women is noticeable. You know, this is not counterintuitive. There's an effect of about 7 points for women. But the effect for men is much more pronounced. We're looking at an effect, a percentage point difference of 22 points. So does partisanship affect gun control opinions the same way for men and women? Well, yes and no. The yes part is yes, in that Democratic women are more in favor than Republican women. But no, in that the size of the effect is much smaller for women than for men. 7 points versus 22 points. That's a fairly common form of interaction. Well, the confusing thing about interaction is it can assume many forms. Let's review what we just discussed. 57% of female Democrats, 4 of 7, are pro-control, compared with 50% of female Republicans. So for women, it's a 7-point partisanship effect. Again, 60% of male Democrats, 3 of 5, are pro-control, compared with about 38%, 3 of 8, of male Republicans. For men, there's a very large 22-point partisanship effect. And here's a line chart. Interaction line charts can often be very interesting, and this is a line chart of the relationship we just discussed. Here's the female line. Let's trace the women first. That point there is 57% of female Democrats, and it drops about 7 points to 50% among female Republicans. So we see this sort of mild slope. It's not zero. It's not flat. I mean, the partisanship is having an effect, but it's much weaker than this huge 22-point drop for men. Interestingly, I mean, there's always something interesting about interaction. Notice in the way I've represented it here in this example that for Democrats, there's a small gender gap, and it's a reverse gender gap here. You know, we've got Democratic males even more strongly in favor of control than Democratic females. So the lines cross. It's sort of a very exotic when they do. And of course, among Republicans, there's just an enormous gender gap. So again, if someone were to say, what's the effect of partisanship on gun control opinions controlling for gender, you have to give a different answer depending on the values of the control. The effect of X on Y depends on the value of the control variable, gender. Interaction really doesn't have a single underlying dynamic. It can assume many forms. It has one identity, and this is the identity. The effect of X on Y depends on the value of Z. This means that interaction can assume several different forms, and it can assume many, but I'm going to show you just some of the basic ones that we often encounter in political research. This is a very common pattern, and it's not unlike the one we just looked at. For one value of Z, the effect of X on Y is weaker than for another value of Z. This would be like a negative sloping representation of that fact. And so the effect of Z on Y differs as well, depending on where you are on X. A small difference here, big difference here. So we have lines going in they're sloping in the same direction, but the strength is much different. Here's a positive, a sloping version of the same idea. And I would say this, if I had to say, I think in most of the relationships you're going to encounter that are interaction effects, this is probably one of these two is the most common form. However, sometimes you'll encounter something like this, and students sometimes mischaracterize this as spurious, and they think it's spurious because from one value of Z, there's no effect of X on Y, as represented by the flat line here, by the flat line here. But it can only be spurious if the lines are flat for all values of Z. Notice when you switch to this value of Z, there's a big effect. This value of Z, there's a big effect of X on Y. So for one value of Z, there's no effect of X on Y. For the other value of Z, there is an effect of X on Y. This is a form of interaction where you must specify which value of Z you're talking about in order to talk about the effects of X on Y. Now I put this in, it's pretty exotic and there just aren't a lot of empirical examples, but it's interesting if you ever encounter this. Notice this is like really interaction because for this value of Z, the relationship is that the Republican actually is more in favor of gun control than the Democrat. And for this value of Z, the Republican is less in favor of control than the Democrat. So for one value of Z, the line slopes upward to the right. It has different direction. It has different direction, even though it looks similar. And this value of Z is completely different in terms of the direction of the effect. This is sometimes called disordinal interaction, and this is a real exotic rendition of that. But I put it into to sort of sensitize you to this possibility that this can happen.